Quantum Mechanics by Maple. Part 9. Reduction of error in numeric or floating point computation. Quantum Mechanics by Maple is a complete course, contains 38 videos for beginners. During this course, student will be able to use Maple step by step in quantum mechanics. The first video of this series explains mathematical expressions, the second video explains mathematical functions, and the third video explains exact quantities and numeric quantities. The fourth video of Quantum Mechanics by Maple discusses the methods for converting exact quantities to numeric quantities. The fifth video of this series discusses the types of computations, including symbolic and numeric computations. The sixth video of Quantum Mechanics by Maple discusses the first type of computation, symbolic, abstract, or exact computation. The seventh video of this series discusses the second type of computation, numeric, or floating point computation. The eighth video of Quantum Mechanics by Maple discusses sources of error in numeric or floating point computation. This video is the ninth video of this series and discusses how to reduce the errors by increasing the number of digits in Maple. As it expressed earlier in previous videos, there are two types of computations. 1. Symbolic, or exact computation. 2. Numeric, or floating point computation. By its nature, numeric, or floating point computation, normally involves some errors. Controlling the effects of these errors are the subject of active research in numerical analysis. Increasing the number of digits allowed in a representation reduces the magnitude of possible errors. The Maple digits environment variable controls the number of digits the Maple uses when calculating with software numeric or floating point numbers. So, the key concepts in this video are increasing the number of digits, reducing errors. By the key concepts, we can simplify the subject by two following questions. 1. How can we increase the number of digits in Maple? 2. How does Maple reduce errors by increasing the number of digits? Now, we are going to find the answers for the questions. Regarding the first question, how can we increase the number of digits in Maple? The Maple digits environment variable controls the number of digits. The default value of digits is 10. The value of digits is changed by using the assignment operator, digits equals n. N is the numbers of digits. For example, if we force Maple to use 20 digits in a computation, then we use the assignment operator, digits equals 20. Regarding the second question, how does Maple reduce errors by increasing the number of digits? Increasing the number of digits allowed in a representation by using the assignment operator reduces the magnitude of possible errors. So briefly, the value of digits is changed by using the assignment operator, digits equals n. N is the numbers of digits. Increasing the number of digits by the assignment operator reduces the magnitude of possible errors. In order to illustrate the questions and answers, let's consider the same example in the previous video. Example: subtraction of nearly equal floating point quantities can result in small errors. If y equals root x squared minus x, x is a number, then find y. In this example, by symbolic or exact computation, the result must be y equals 0, but result reported by Maple or a typical calculator is not always 0. As we calculated in previous video, for example, for the following data. If x equals 0.00011 and x equals 0.00038, then y equals 0. But, for example, for the following data. If x equals 0.0005 and x equals 0.00083, then, when we use the default value of digits, 10 digits, y is not 0. Let's increase the number of digits for the last two data and see the results. As it expressed earlier in previous video, for the first data, by the default value of digits, 10 digits, the result by Maple is and, for the second data, by the default value of digits, 10 digits, the result by Maple is The results show there are small errors in numeric, or floating point computation. As we know, the result must be 0. Increasing the number of digits to 15 digits by the assignment operator for the first data changes the result as follows. And increasing the number of digits to 15 digits by the assignment operator for the second data changes the result as follows. Increasing the number of digits to 15 digits for the first data results in exact answer, and for the second data results in a smaller error. Increasing the number of digits to 20 digits by the assignment operator for the second data changes the result as follows. Increasing the number of digits to 20 digits for the first, and as well, second data, results in exact answers. In the next video, we will discuss how to restrict the domain and force Maple to perform computations in the real number system.